All right, today's lesson is on even, odd functions, or neither. There's a rule to determine if a graph is an even function. It's a very simple test. It must be symmetric with the y-axis. What that means is if you cut it in half at the y-axis, the left side would fold right over on top of the right side. I'll show you some examples in a minute. There's a rule to determine if the function is an odd function, and that has to be symmetric with the origin. A very, very easy test to see if a picture, a graph, like these first six, are symmetric with the origin. You just rotate it 180 degrees, and if it's the same exact picture, then we say it's an odd function. If you fold it over the y-axis and you get the same picture, it's the same function. So if you look at this first one, there's the y-axis, okay? I'm just cutting this in half. If I folded that over that line, would I get the same function? No. So this is not an even function. For it to be symmetric with the origin, or an odd function, if you rotate this 180 degrees, you get the same picture. You'll notice this is not the same picture. So this is not even, and it's not odd, so we'd say this is neither. This next one here, if you folded the right side over onto the left side, you fold this side over, it would land right on top of that. You fold this side over there, so we say this is an even function. It's symmetric with the y-axis. Exactly the same as this one. If you folded it over the y-axis, you would get the same exact picture. So that's an even function. This one, if you folded this over the y-axis, notice there's no graph over here, so it's not even. Could it be odd? Well, remember this picture. It's up on the right, which is quadrant 1. It's down on the left in quadrant 3. If I rotate this 180 degrees, notice it's still up on the right, down on the left. It's an odd function. Okay, so this is an odd function. This one here, if you flip this over the y-axis, there's no graph over there, so it's not even. If you rotate it 180 degrees, do you get the same picture? Yeah, it's the same picture. So this one is an odd function. If you flip this over the y-axis, that means the graph would look like this. It's not over there. If you rotate it 180 degrees, that's below the x-axis now. Here the original picture is above, so this one would be a neither. Now there's also a rule to determine if an equation is even or odd, and that rule is this right here. And I'll show it to you, but there's an easier way. If you substitute negative x in for every x, and you still get the same exact equation, we say that's an even function. For an odd function, if you substitute in a negative x, you get the complete opposite. It means every term is opposite of the original. So I'm going to do this test, but then I'm going to show you a really, really easy way to do this. So the test for both of them is the same. Notice they both are replaced, the x is replaced with a negative x. Well, just like we did on evaluating functions, I'm going to substitute that in wherever there's an x. And if you do that, when you square that, you're going to get a positive. Now notice, when I substituted negative x in, I got the same exact equation. Nothing changed. So that means if that happens, you get the original equation, we call this an even function. But there's a really, really easy way to tell if a function's even or odd. Let me write this in a little darker. Just by taking a look at the exponents. This exponent is a 3. This one's not written. That's a 1. I notice 3 and 1 are both odd. This is an odd function. If I used this test, that would change the signs of both terms. All right, this one, now this is a tricky one People make a mistake on this all the time. This is an exponent of 1, but any constant term has an exponent of 0 on the x because any number to the 0 power is 1. So I have one odd and one even, so it's not odd, it's not even, it's neither. So you have to put that constant or the x to the 0 for the constant. So very simple. If it has a constant, it cannot be an odd function. It could be even, but it cannot be odd. Like on this one would be x to the second minus 5x to the 0, because all constants are times x to the 0, because any number to the 0 is 1. So I have an even exponent here. I have an even exponent here. Therefore, this is an even function. Okay, now, again, any equation that has a constant cannot be an odd function, because that first exponent on the x is a 1, this one's a 0, that's odd, that's even, so this is a neither. You got to be really careful on this one. We haven't learned how to expand this. You can't just look at that and say that's an odd function, because this means x plus 1 times x plus 1 times x plus 1. And we learned the other day that square squared double the pair, so this is x squared plus 2x plus 1. And then you'd have to multiply that by this x plus 1. But when you multiply these two, you get an even. When you multiply these two, you get an odd. So don't worry too much about that one. It is neither. It's not even, it's not odd. It's got both exponents in there. On the other side, page 2, it's just some more of the same stuff. I mean, this is the test. This is the test for even. Okay, and that's what this says. A function is even if and only if whenever the point x, y is on the graph of f, then the point negative x, y is also on the graph. That is just saying, like, if this point, if you look at this point right here, let's just say that's 2. This is 2, 5. What this is saying here, then negative 2, 5 must also be on the graph. They're just changing the sign of the x. So if this is true, it's even. And here, negative 2, 5. Okay, but the easiest test is just to check, is it symmetric with the y-axis? If you flip it over, does it give you the same picture? All right, prove this. We can prove it using this rule. Wherever there's an x, replace that x with a negative x. Simplify that. Square a negative, you get a positive. Notice when I do that, I get the same exact thing, but I knew that was going to happen. I knew this was an even function because that's an even exponent, and 1 would be 1x to the 0. They're both even. And for the odd, again, here's the test. Substitute in negative x. They're saying now that if you change both signs, like this one, say this is 2, 3. Oops, 2, 3. Then according to this, the ordered pair negative 2, negative 3 should also be on the graph. Negative 2, negative 3, same thing. But our test, simple test, if you have a picture, rotate it 180 degrees. If you get the same picture, it's an odd function. Now, because this is the only exponent in here, I know this is an odd function. The proof, again, is replacing every x with a negative x. So wherever there's an x, replace it with negative x, but a negative times a negative times a negative is a negative. Now notice this equation is the opposite of that one, and that's what this rule says. If you plug in a negative x and you get the opposite, then it's an odd function. We don't have to go through all that. This one right here, it's not symmetric with the y-axis. If I flip it over the y-axis, I don't get the same picture. If I've rotated 180 degrees, that is not the same picture. See, notice here, this point is below the x-axis, but when I rotate it, it's above. So that's not even, it's not odd, this is neither. This one, If you fold it right across this y-axis, you'll get the same picture. This is an even function. Number 3, if you rotate it 180 degrees, notice this goes in quadrant 1 and quadrant 3. If you rotate it 180 degrees, quadrant 1, quadrant 3, therefore this is an odd function. Remember, every constant term is x to the 0. So I have an odd exponent, I have an even exponent. If they're both odd, it's odd. If they're both even, it's even. If you have one of each, or some even, some odd, it's neither. And again, remember, a constant term, if it has a constant term, it cannot be an odd function. This one has a constant term, it cannot be odd. This is an even exponent. Any constant term can be written times x to the 0 power. That's also an even exponent. All my exponents are even, therefore that function is even. This homework should be nice and quick. Use your notes though, and ask for help.